As I mentioned yesterday, today's topic of discussion is very important. See. So we are going to see a new branch of mathematics, which is, what is it called as? 1 minute. Yeah. So we are going to see a new branch of mathematics, which is called as calculus. Okay. So the chapter that I'm going to teach you now is going to create the base for the whole calculus for your next year. Next year, remember 35 marks from your 80 marks is only calculus. Okay, you have so many chapters, but you need to, the base for everything starts from here, limits and derivatives. Okay, listen to it carefully. So, what exactly do we mean by limits and derivatives? That's what we need to see. Okay, so limits and derivatives are basically like, how do I say, like they are the base for you to find some important factors related to a function, right? So this chapter will again get related to the concept of functions. So before that, let's recollect certain facts. So everybody knows what a function is. So function is a special type of relation where one input has only one output. So here input means what? Input means every point in the domain will be linked or will be mapped only to one particular point in the codomain, right? That is, if you have two sets, A and B, okay. If I have elements like x1, x2, x3, so on till xn, y1, y2, so on till yn, then if x1 is related to y1, then it should not be related to any other term in, or any other element in set B. Okay. So if every element in set A is associated only to one element in set B, then we call that as a function. Then we saw the different kinds of functions. You guys remember what are the different functions we have seen? The different types of functions that we have dealt. We would have seen what is an identity function. Then we would have seen what is a trigonometric function, exponential function, logarithmic function, all these things are there, right? And at that point, I would have also explained using a graph. If I ask you what is an identity function, if you see a shape like this on a graph sheet, okay, where you say y is equal to x, then y is equal to x is what is called as a identity function. Similarly, trigonometric function, when I say trigonometric function, if I see a graph like this, then by looking at it, what can I say? What type of a trigonometric function is this? Guys, what type of a trigonometric function is this? This is sin x, right? So if I draw a graph like this, what function is this?
Cos x.
That's right. So it is cos x. Okay. So if I draw a graph like this,
Tan.
very good. So this is a function called as tan x. Okay. So like this, you can, whatever function I give you, function is nothing but if I give you the function in the form of a mathematical equation which relates y to x. Okay. Sin x means you are saying y is equal to sin x. Cos x means y is equal to cos x. Here, y is equal to tan x. So when you're writing a function, you will ensure that the left-hand side is always a dependent variable and the right-hand side will be an expression in terms of independent variable. Am I right? So that's what you do mathematically. And for a function, you have two important terms associated to them. What are they? One is called domain and the second is called range. This also we have discussed. So can someone tell me what is the domain? So what do you mean by domain? I asked a very simple question. What is domain? Set of what? Set of all. Is it input values or output values?
Input values, sir.
Input values.
Set of all input values for which what kind of an output is expected? For which a finite output is expected. Means, for example, if I have y is equal to sin x, okay, so I need to think of the values of x that I can substitute so that I get a finite value of y. In that scenario, if I think whatever is the value of x that I am going to substitute, the value of y is always going to, in the case of sin x, the value of y will always be finite because the maximum value of sin x graph that it goes is 1 and the least value to where it goes is -1. So that is why we say for sin x, the domain is x belongs to R and y belongs to -1 to 1. Right? Similarly, when I ask you about cos x, what will you say? X belongs to R and y belongs to what? -1 to 1. Can someone tell me for tan x?
Sir, minus infinity to infinity will be the range.
Minus infinity to infinity will be?
Range. Domain is all real numbers.
Think about it, Meenakshi. There is a mistake. It is not all real. So domain is x belongs to all real numbers except few numbers. What are they?
Sir, numbers like 90.
Yes, 90. So multiples of 90. What multiples of 90?
90
Is it
to
even multiple? Is
odd
it even
number.
multiple? Yes. R minus 2n plus 1 into pi by 2. This is the domain. So the meaning of this is, for you to define tan x, you can substitute any real number between minus infinity to infinity except odd multiples of pi by 2. Because when I substitute pi by 2 in the case of tan x, tan pi by 2 is going to give me infinity. But what is the definition of domain? Tell me. Domain is only set of those input values which is giving me a finite output. The number should be a finite number. It should not be an infinite number. Right? That is why x belongs to R except 2n plus 1 into pi by 2. And the range is going to be minus infinity to infinity. That is, you substitute any value of the number from the domain, you can get if you prepare a table, right? If you prepare a table writing all the values that are possible, the table will have all the y values between minus infinity to infinity. Guys, concentrate. There is a reason why I'm saying all these things. Am I clear till this step? So I hope you're able to recollect what is this domain and range concept. Right? Is it clear? Is there any point which is confusing or tough? Everybody? Clear. Okay. So now I will proceed. Now comes an important question. Why am I speaking about functions in the case of limits? Okay. So first we will see limits and derivatives. We'll see derivatives means most of the physics students would have learned. It is differentiation, like how you do in physics. But others, commerce students, need not worry about it. We will see slowly. You don't worry about it. Just concentrate. Okay. So now I'm going to speak about limits. So I will explain it like this. I'll put it in very simple terms. When I speak limits, I'm talking about limit of whom? See, you're going on a road, you'll see a signboard saying that the speed limit is 60 km/h. So you're talking about the limit for that speed. So that is the minimum value below which you're supposed to go. above which it is not allowed, permissible to go on that road. Right? In a similar context, when I speak about limit, in case of mathematics, what limit am I trying to talk about? What is that limit I'm interested to study about? Limit of whom? That's what we are going to answer in this chapter. When I say limits, I am trying to speak about the limit of a given function. Okay. So what do I mean by limit of a given function? Okay, rather I'll be more specific. Limit of a given function within its domain. So when you want to find the limit of a function, the question is about finding the limit of a function. Okay. When I say limit of a function, you're going to find its limit within a parameter called its domain. Okay. So try to understand, guys. See, I have a sin x graph, right? So what is the domain of sin x that I told you? So domain of sin x is all real numbers. Means I can substitute any value from minus infinity to infinity in the place of x for sin. The value of y will be a finite number. All right. So you guys tell me here x corresponds to angle and y corresponds to the output value. So what is the value of x here, guys? The first red dot that I put, what is the value of x?
0.
0.
It is 0. What is this value? Tell me in terms of radian. Don't tell me in angles. I mean degrees.
Pi.
No.
Sorry, pi by 2.
It is pi by 2. Sin 90 is 1. 90 is nothing but pi by 2. Then what is this angle?
Pi.
Pi. Then what is this angle?
3 pi by 2.
3 by 2.
It's called 3 pi by 2. And this is 2 pi. Okay. This is called a complete cycle. Meaning I have a positive cycle and negative cycle. They both are symmetric, right? If you look at them graphically, they both will have symmetric shape. Okay. This is called as a complete cycle. So though the domain of sin x is a real number, here what I did is I used the concept of restricted domain. So restricted domain means I'm choosing a particular domain from the bigger set. Like the domain for sin x is this much, but I'm choosing a value between 0 to 2 pi. I'm interested to study what is happening in this particular region. Okay. So this is called as restricted domain. So 0 to 2 pi is restricted domain for sin x. In that restricted domain, listen to me carefully, okay? In that restricted domain, if I raise a question saying that check the limit of sin x at pi by 2, okay? If I put a question like this, I want you to check the limit of sin x at pi by 2. Then the meaning of this is, first, sin x is a function. So sin x is a function. So if I say y is nothing but f of x, right? That time at that point I told you y is f of x. So if I ask you what is the value at pi by 2, that is what is f of pi by 2, what will you guys tell me? It is sine. So wherever x is there, you will substitute pi by 2. What is the value that is going to come out?
1.
It is 1. So the actual number that I have found out is called as function value. Function value means the name itself is suggesting value of the function at which point? At x is equal to. So what have I done? I have found the value of the function at x is equal to pi by 2. Is it clear till this step? Am I clear? Guys, if you give confirmation, I can proceed. Or else I need to know what is the
last step again.
Which step?
Last.
So this one, huh? See, the function that I've taken is sin x now. For sin x, I am interested to study the property of sin x between what range, between what values of x?
0 and 2 pi.
0 to 2 pi. So between 0 to 2 pi, pi by 2 is one of the points. Am I right?
Yes, sir.
So what I'm trying to say is, I want to know what is happening to sin x at pi by 2. I'm interested to study the property at this point. Means, to put it in simple terms, I will zoom like this and see. I will go out and see. I'll see how the shape of the graph is. So that is what I'm trying to do. So if I substitute x is equal to pi by 2 in sin x, then what is sin pi by 2? Sin pi by 2 is mathematically 1. According to trigonometry, it is 1. But according to functions, that 1 is nothing but the function value of sin x at x is equal to pi by 2. So every point on this graph will have a function value. So the meaning of this 1 is nothing but x is pi by 2. So what will be the coordinate of this point? Pi by 2 comma 1. So when I give you a point like this, I'm trying to tell you when the value of x is pi by 2, the value of y is 1. So the value which you are writing for y-axis is what is called as the function value. Similarly, if I ask you what is the function value at 0, what will you say? So when I say function value, no, function value at 0 is only y coordinate. Y coordinate is the function value. 0, 0 is the ordered pair. So what is the function value of sin x at x is equal to 0? You should only tell the y value. So y is equal to sin x. What is y of 0? It is sin 0. What is sin 0? 0. So the function value of sin x at x is equal to 0 is 0. Okay. So try to understand 0, 0 is ordered pair. This is the value of x. And the value which you're getting here is called as the function value. So the ordinate value, abscissa and ordinate, right? The ordinate, the value of y that you're getting is what is called as function value. Am I clear now? So like this, if I talk about sin x, between 0 to 2 pi, how many such function values can you find? Between 0 to 2 pi, how many such function values can you find? So how many function values can you find? It is infinite. Infinite values you can find because the graph is having many function values like that between 0 to 2 pi itself. Means think between minus infinity to infinity, you can find many such. Okay. But here, the concept of limit is to check. Okay. Now listen. Now I will tell you why we are actually studying limit. Then I'll explain what limit is. So the reason for studying limit is, write it down. It gives information regarding the continuity of a function. So underline this word continuity. In your 11th standard, nowhere it is used. But if you understand this, you will have a better clarity of why you're doing all the problems. Okay. It gives information regarding the continuity of a function. Please underline that word continuity. I'll explain what continuity is. Shall I proceed? Guys, shall I proceed?
Yes, sir.
Yes,
So,
sir.
I'm taking two examples. X-axis, y-axis, x-axis, y-axis. So what graph is this? This is y is equal to tan x. This y is equal to sin x. Okay. So, okay, wait, I'll draw a better graph. Okay. The 0, pi by 2, pi, 3 pi by 2. Okay. So I'm putting a question again like this. I want to see if a question comes like this. Check the limit of a function at a particular point. Limit with respect to a function can be checked only at a particular point. Okay. Suppose I put a question like this. Check the limit of the function at y is equal to sin x and check the limit of the function y is equal to tan x at x is equal to which point? Pi by 2. Then indirectly what I'm asking is, when I put a question like this, I'm asking you what did I say is application of physics, application of limits. It gives the information related to continuity of a function, right? So look at both the graphs, guys. Tell me which graph is continuous.
First one.
First one, sir.
So without a doubt, you people told the answer is first one. Why? Because why do you feel it is continuous? Why is the second one not continuous? I'm able to see the graph is continuous only. Right? I didn't take my pen out while drawing this graph. So the red color part when I drew, I didn't remove my pen. It is continuous only. But what made you say that it is continuous? What is your understanding about continuity in mathematics? So whether right or wrong, you just
Keeps
tell me.
on going.
It
The
keeps
value
on
just
going.
keeps on going.
So yes, the value keeps on going. So what is the so when I told that tan x is also continuous, what is the mistake I did? Tan x is continuous for sure in this region, but I'm talking about the continuity at which point. I'm interested to study the continuity at which point. X is equal to pi by 2.
Pi by
Right. So what is happening is, as soon as I reach pi by 2, at this point, okay, look at this. At this point, I am forced to remove my pen and again start drawing the graph. Whereas with respect to sin x, I need not remove my pen at all. I need not leave the contact between pen and the paper. I'm able to continuously draw it. That is the basic meaning of continuity, right? If you're able to draw a continuous line curve, we call the function to be continuous, right? So how limits is going to help us is what we are going to see. Okay. Now see, concentrate, guys. So I already told you what is function value. Is that point clear? Function value is clear, right? Okay.
Yes, sir.
Now see, what I'm going to do is I'm zooming this. Okay, I'm zooming this. I'm not able to see any break here. I'm not able to see any break on the graph sheet. Now see, what I'm going to do is slightly, okay, you're able to see dotted lines that I'm drawing. So this, by the way, it's a zoom version. So beside this point pi by 2, I'm going to consider a point h. Okay, at a distance h, I'm going to consider a small point. Similarly, on the left of it, I will consider a point, which is also at the same distance h. So when I zoom out, look at the way they are so close to each other. Guys, are you able to understand?
yes,
So
sir.
now listen. So when I draw this graph, or see, I'm looking at the graph like a shape. When I draw this shape, I can approach this point either from the left-hand side, I can approach from the left-hand side, or I can approach from the right-hand side, or I can directly find the function value. Yes. You're able to understand this.
Yes, sir.
right? So what should happen is, when I say you need to check the limit of a function at a particular point, whether you approach that particular point x is equal to pi by 2 on the graph, okay, whether you approach that particular point from the left hand side or from the right hand side, or directly you take the function value, if all the three values are coming out to be the same, then that particular function is said to be continuous. In terms of your 11th standard, we call as limit exists. So continuity of function means limit existing. So what I'm going to do is, I'm going to check the limit of the function at x is equal to pi by 2 mathematically to verify if all the three values are same. Whereas if I talk about tan x is equal to pi by 2, I'm repeating it. If I talk about tan x is equal to pi by 2, this is pi by 2, guys. When I approach pi by 2 from left hand side, where is the function value going? Where is the function value going? It is going to plus infinity. When I approach from right hand side, where is it going to?
Minus infinity.
It is going to minus infinity. So when I approach from left hand side, it is saying it is going to plus infinity. When I approach from right hand side, it is saying it is going to minus infinity. So this kind of a point, this kind of function is said to be discontinuous.
Sir.
Means, yeah, tell me.
But from right hand side, it's going to plus infinity only, sir.
No. Look at it. No. When I come this side, where is it going? Look at the graph.
Okay, sir, for second graph, sir.
Yeah, second graph. No. See, on the right, see, to put it in simple terms, on the right of pi by 2, what is happening? On the left of pi by 2, what is happening?
Okay, sir, now I'm clear.
Okay, that is the meaning of approaching from right side and left side. Okay. So I hope you are able to slightly understand what is the difference between continuous and a discontinuous function, right? Is that point clear? So to put it in simple terms, I can say y is equal to sin x is continuous at x is equal to pi by 2, whereas y is equal to tan x is not continuous at x is equal to pi by 2. Can I conclude the story like this?
Yes,
right?
sir.
Now see, continuity is the application term. But to check the continuity, what exactly we are doing is we are actually checking the limit of a function at that particular point. So the steps that we are going to follow to find whether the limit exists at that point or not is checking the limit of a function at a particular point. Okay. The first thing that we'll calculate is something called as left limit. The meaning of this left limit is you are approaching the particular point, that is in the previous example pi by 2, from the left hand side. That is the meaning of left limit. Okay. Now see. So now I'm going to deal with some general functions. So if I take a function like this, if I take a point x here, okay. So if I have to approach from left hand side, I need to have a point which is very, very close to x. Okay. Which is at a distance h from the point x. If this point is x comma 0, what will be the coordinate of this point is? So this point is x comma 0. So what will be the coordinate of the point on the left of it?
X minus h comma 0.
So what I'm going to do here is, okay, what I'm going to do here is observe. See, if I say this point is x comma 0, what will be the corresponding point on the graph? So if this is a function y is equal to f of x, I will take this point as, for example, if I take it as x naught, this will also be x naught minus h. So what will be the corresponding point on the graph? It will be x naught comma. If I substitute x naught in f of x, what will be the y value? It will be f of x naught. Am I clear with this point?
Yes.
So it's like how you solve polynomials, right? I just take that x naught and substitute it there. Similarly, what will this value be?
X naught minus h comma f of x naught minus h.
That's it. Okay. So x naught minus h comma f of x naught minus h. I hope you understood how to take these points, right? So what I need to verify is this x naught minus h will be equal to x naught under what scenario? Suppose
When h is
x naught-
0, sir.
yes, when h is 0 or h is tending to 0. That's what I was about to explain. See, for example, I give you a function like this, y is equal to x. It's an identity function. I am asking you, what is the function value at x is equal to 1? What will you say? Function value means value of y. So you will take and substitute it here. The function value is 1. Okay. If I ask you, what is the function value at x is equal to 0.99999? What will your answer be?
Approximately for 1, sir.
It is approximately 1, right? Means what we are trying to say is from this point 0.0000999, that is what is x naught minus h. From this point, as I move towards the point 1, so when I look it on a graph sheet, 1 is here. See, this is slightly a zoomed version that I'm drawing. 0. Some, let's say 59s are there like this. From this point, when I am approaching towards the point 1, from which side am I approaching?
The left side.
So left side, right? So when I am approaching from this point towards 1, where is my function value tending to? Tending to means approximately
Tending to
where
1.
it is tending to 1. It is not exactly 1, right? I'm not talking about exact value. I'm talking about approximate value. So approximately it is tending towards 1. So what this is trying to tell us is this particular function y is equal to x, when you draw it on the graph sheet like this, if this is 1, okay, if this is 1, and if this is 0.99999, okay, when I go in this side, I know that when I draw the graph, it is going towards 1, which is nothing but the function value at x is equal to 1. You're able to understand this? So what I'm going to do is, the steps that we need to follow for left limit are, see, we write something like this. LIM stands for limit. Limit of here, x naught minus h will become x naught under what scenario? I'm repeating it again. When the value of h is very, very, very small. When I say the value of h is very, very small, I can use something like this. So how you read is limit h tends to 0. So you read it as limit h tends to 0, f of x. This is what is called as left limit. Okay, actually one small correction. Limit h tends to 0, f of x naught minus h is what is called as left limit. Guys, it will
Always
take
it will
time.
tend to 0, sir.
It should tend to 0. That is how we define. If I say left limit at x is equal to, if I say left limit at x naught, means from x naught minus h, where x naught minus h is that 0.00999, I am approaching towards x naught, where x naught is that 1. So I'm approaching from left hand side. So this is like a formula. As of now, have it in your mind now. When I explain examples of how to apply it, you will understand. Okay. So when I say, for going forward, when I say I ask you to calculate left limit, there is the formula that you're going to use. Limit h tends to 0, f of x naught minus h.
So then, sir, we have to. So then that means we have find the functional value at x naught, sir.
You're checking the functional value of x naught approaching from left hand side. See, there are two things. Whatever formula I've given here is actually called as left limit. If I use what is the function value at x naught, that is function value. Left limit and function value are not the same according to definition. Okay. So when I say function value, you have to take that point and directly substitute it in the function. That is the meaning of function value.
Okay, sir.
Okay. Whereas when I say left limit, you will do all this. You will follow all these steps. Similarly, you will understand it slowly. Okay. By the end of this class, you will understand. Don't worry. When I do some examples, you will have clarity of what it is. Similarly, I can approach the same point x naught from the right hand side also. So the same graph taken, this x naught. For me to approach from right hand side, what should the point on the right hand side be? Should it be less than x naught or greater than x naught?
Greater than x naught.
It should be greater than x naught. So for that, what I'm going to do is, I will consider a point which is at a distance h from x naught. So what will be the coordinate of this point, guys?
X naught plus x.
X naught plus h. So what will be the points on the graph? X naught plus h comma
Function.
f of x naught plus h. Similarly, you guys tell me what will be the right limit. Limit h tends to 0, f of
X naught plus h.
that's it. Okay. So these are the so-called formulae for us to check the limits. So based on this, I'm going to give you some important steps. Write it down. If left limit is equal to right limit is equal to function value. If left limit is equal to right limit is equal to function value, then the given function is said to have its limit to exist at the given point. Okay, just write it down. No, see. Listen. Check the limit of function at x is equal to pi by 2 for sin x. Now I'm not going to draw any graph, okay? So for me to check the limit of a function at x is equal to pi by 2, when a question like this is asked, it means they're asking you whether the limit at that point exists or not. Okay, if limit has to exist, what should happen? Left limit should be equal to right limit should be equal to function value. Okay. So step number 1. What is the left limit? What is the left limit formula?
Limit of f into x naught minus h with h
Limit
tending to
h
0.
Limit h tends to 0, f of x naught minus h. Okay. So limit h tending to 0. Here, what is the function? sine. Okay. Did you understand? In the place of f, I wrote sine because sine x is a function. In the place of x, what am I supposed to write?
0, sir.
X naught minus h. So at what is the point x naught here? At what point am I asked to check the continuity?
Pi by 2.
So I will write it as sine of pi by 2 minus h. Did you understand what I did? Since f of x is sine x, x naught is pi by 2. Okay. So limit h tends to 0. Don't be in a hurry to take this and substitute it here. You first need to expand the function and then do it. Sine of a minus b. What is it? Sine a cos b minus cos a sine b. Right? So cos pi by 2 into sine h is what? 0. So now it will be like this: limit h tends to 0, sine pi by 2 into cos h. Okay. So whatever is a constant value can be taken out. Okay. So listen, limit h tends to 0. What is sine pi by 2? It is 1. H tends to 0 if I substitute it here. What is cos 0? Sorry. Wait. Cos h. Okay. Now I'll substitute h tends to 0. So I'll get 1 into cos 0. Now the limit should be removed. So what is 1 into cos 0? What is cos 0, guys?
That's 1, sir.
Okay. Cos 0 is 1. So what I'm trying to say is the left limit is 1. The meaning of this is for a graph, for a sin x function, when you approach towards pi by 2 from the left hand side, from a point very, very close to it, you are actually going towards a function value of how much? You are going towards a function value of 1. Similarly, step 2 is right limit. Okay. So for right limit, what is the formula? Limit h tends to 0, f of x naught plus h. That will be limit h tends to 0. F of x naught plus h means it is sine of pi by 2 plus h. What are we supposed to do? I told you not to substitute the values without simplifying it. Sine pi by 2 minus h. Sine pi by 2 cos h plus cos pi by 2 sin h. This value will be 0 because cos pi by 2 itself is 0. So limit h tends to 0. So till you're not substituting that 0 in any of the places of h, you need to follow this procedure. Limit h tends to 0. Sin pi by 2 is 1 into cos h. Now substitute the value. So 1 into cos 0 is 1. So what this is telling is, when you approach the function from right hand side also, the final output is coming as 1. So what is function value? Third step is function value. So function value means, what did I say? Sine of this is also 1. So what is that you're able to understand from this case? Mathematically, left limit
equal to
is
right
equal
limit equal to function value.
So for this graph, limit exists at x is equal to pi by 2. So by now you should have understood, when I say limit exists, it should also run in your mind that is a continuous function. So when you draw a graph, you need not move your pen from the paper. I hope you are making a note of this.
Yes, sir.
Okay. Now I will do the same thing for tan x and shows. Check limit of function y is equal to tan x at x is equal to pi by 2. So left limit, what are we supposed to do? Limit h tends to 0 f of x naught minus h. Right? That is limit h tends to 0. What is the value of f, guys? What function is this? Tan. You guys tell me, in the place of x naught, what should I write?
Pi by 2, sir.
Yes. Pi by 2 minus h. Okay. Now you will understand. Okay. Right limit also, I will write it off. Right. I'll leave some space and then I'll write. Right limit. Limit h tends to 0. F of x naught plus h. That is limit h tends to 0. It will be tan of pi by 2 plus h. So if at all you take this h is equal to 0 and substitute it here, what will you get? You will get tan pi by 2. Here also you substitute 0 here, you will get tan pi by 2. In both the cases, what is the answer coming out as? Infinity. If I ask you what is the function value, what will you say?
Infinity.
Function value is tan pi by 2. So that is also infinity. Now, left limit is equal to right limit is equal to function value. So this is telling us that the limit is limit is existing. If the limit is existing, the function is continuous. But what is the graph telling us? So when we drew the graph at x is equal to pi by 2, what is it we had to do? At x is equal to pi by 2.
Discontinue and start again.
Yes, we had to discontinue the process of drawing and then we had to start, right? Because when you approach pi by 2 from the left hand side, the graph went to plus infinity. When you approach pi by 2 from the right hand side, the graph went to minus infinity. Right? So there is a mistake in the procedure that we did. That is happening because you have substituted h is equal to h tends to 0 even without simplifying it. So first we need to simplify, then we need to apply it. So for that, what we are going to do is, it is limit h tends to 0. What is tan pi by 2 minus h? It is cot h. Right? So when you take this and substitute it here, you will get infinity. Because cot 0 is infinity. I'll write an extra step. Okay. Whereas when you do right limit, what is tan of pi by 2 plus h, guys?
So tan a plus b by 1 minus tan.
No, you need not do all those things. No, tan pi by 2 plus h. Tan of pi by 2 plus theta, your trigonometry. It is minus cot h. Okay, now you substitute h tends to 0, it will be minus infinity. Now are you guys able to understand? So the left limit, tell me.
So in the previous question, then why did we expand it according to formula, sir?
You could have written like directly also. In both the cases, you would have you could have written directly also. Sin pi by 2 minus h is cos h. Sin pi by 2 plus h is also cos h. That also you could have done. Okay. Whereas here, we use the direct formula. See, if you want, you can use the tan pi by 2 plus h by tan pi by 2, 1 plus tan pi by 2 into tan h. But that will be a complicated procedure. It's better we go with this. Okay. So left limit is coming out as plus infinity, right limit is minus infinity, and the function value is infinity. That is why if you see the graph is like this: pi by 2, right? When you approach from right hand side, the value of y is going to minus infinity. That is the meaning of right limit. When you approach from left hand side, the value of y is going to plus infinity. That is the meaning of left limit. Exactly at pi by 2, it is plus infinity. Okay. So here, what will you say? Will the limit exist or it doesn't exist?
It does not exist, sir.
Limit does not exist. So this is all about limits actually. Okay. So to put it in simple terms, wherever they ask you limit exists or not, you need to follow this procedure. By doing this, you will be able to speak about whether a given function is continuous or discontinuous. Shall we do some problems?
Yes, sir.
Yes. So this chapter number 30. Okay. Now listen. So if the question is find the limits, if they say find the limits at that particular point, you can directly substitute that point and solve it. For example, limit extends to 1. If they ask you the question like this, so limit extends to 1, x cube minus x square plus 1. You can just take this 1 and substitute it here. You need not sit and calculate the left limit and right limit. Left and right limit is calculated only when you need to find whether the limit exists. Okay. So what is the limit extends to 1 in this case? 1 minus 1 plus 1. Answer will be 1. Second, limit extends to 3, x into x plus 1. Just substitute it directly.
Answer
3,
12, sir.
that's it. Limit extends to minus 1. 1 plus x square plus so on till x power 10. So when you substitute minus 1 in the place of x, you will get 1 minus 1 plus 1 minus 1 plus 1 minus 1. It keeps on going till 1. Okay. 1 and 1 will get cancelled. 1 and 1 will get cancelled. So how many terms are there from x to x power 10? There are 10 terms, right? So every 2 terms will get cancelled. So here you have 10 terms and here you have the 11th term. So what will answer be? Even number of terms get cancelled. So what is it you're left out with?
Five.
Sorry?
5.
5.
1.
It is 1 only. No? See, I start from here, okay? Minus 1 plus 1. Next will be x cube.
Yes, sir.
X cube
1,
is
sir.
got it right? Huh?
Sir.
So those 10 terms will get cancelled and this 11th term will be left out. That's why it is 1. Limit extends to 1. X square plus 1 by x plus 100. Directly substitute it. 1 plus 1 divided by 1 plus 100. It is 2 by 101. Now comes the challenge. See, when I substitute x tends to 2 here, what is going to happen? 8 minus 16 plus 16. Sorry, 8 minus 16 plus 8.
8, sir.
Yeah. 8 minus 16 plus 8 divided by 4 minus 4. Here the challenge is numerator is 0, denominator is also 0. 0 by 0 is called as indeterminate form means you cannot find the value of it. 0 by 0 is mathematical absurd. Similarly, infinity by infinity is also called as indeterminate form. Whereas the valid forms are finite value by 0 or finite value by infinity. See, finite value by 0 is infinity. Finite value by infinity is 0. Are you guys able to understand what I'm trying to say? So numerator
Yes,
and
sir.
denominator cannot be simultaneously 0, or numerator and denominator cannot be simultaneously infinity. But numerator can be a finite value and the denominator can be 0, or the numerator can be a finite value and the denominator can be infinity. The numerator is finite and denominator is 0, the output value is infinity. The numerator is finite and the denominator is infinity, the output value is 0. So in this case, I am not allowed to substitute x is equal to 2 directly. Why? Because I'm getting 0 by 0 form. 0 by 0 form is meaningless. So for these type of questions, what you're supposed to do is, first you need to simplify and cancel the common terms. So x cube minus 4x square plus 4x. Okay. You guys know how to divide, right? X cube minus 4x square plus 4x when it is divided by x minus 2, or when it is divided by x square minus 4 itself. Then what are you going to get? You will put an x here. You know how to divide a polynomial with another polynomial. So you will get x cube minus 4x. So x cube will get cancelled. Right? 4x and 4x will also get cancelled. What is that you are left out with? Minus 4x cube. Right? So 1 minute, wait. I'll give you an easier way to solve this. See, tell me guys, in x square minus 4, look at the denominator. I am going to get x minus 2 into x plus 2, correct? A square minus b square, I can write it as a minus b into a plus b. So by substituting x is equal to 2, in x minus 2 or x plus 2 is going to give us 0. In which one, if I substitute 2, is it going to give us 0? So I have two terms in the denominator, x minus 2 and x plus 2. Substituting 2 in which term or which factor will give me
x minus 2, sir.
X minus 2, right? So I need to ensure that that x minus 2 will get eliminated in the denominator, in the numerator also, right? So for that, I need to write this in the form of x minus 2. How do I write it? So for that, what we can do is x cube minus 4x square plus 4x is there, right? If you take out x common, then it is x square minus 4x plus 4, accepted. So x into, this is x minus 2 the whole square. Guys, am I clear?
Yes, sir.
So x cube minus 4x square plus 4x is nothing but x into x minus 2 the whole square. Now if I cancel this x minus 2 and this x minus 2, now I'm allowed to substitute 2. Then what will I get? When I substitute 2, what will I get? 2 into 0 divided by 4. So 0 divided by a finite number is a 0. So whenever you get this so-called indeterminate form, what are we supposed to do? You need to simplify the numerator and denominator and cancel the common terms and then proceed. I hope this problem is clear.
Yes, sir.
So we'll do. So it's the same question in the reverse order. There, if it was a by b, here it is b by a. So I can directly do it. Limit x tends to 2 x minus 2 into x plus 2, the whole divided by x into x minus 2, the whole square. So x minus 2 gets cancelled. So 4 divided by 2 into 0. What will be the answer? finite by 0. I told you something. Finite by 0 is what?
Infinity.
Right? We'll do one last problem. So we'll do this, guys. So first you directly substitute and see. So when you substitute, you're getting 8 minus 8 divided by 4 minus 20, sorry, 4 minus 10 plus 6. So what form is it coming out as? 0 by 0. So it is not, so indeterminate form. So what are we supposed to do?
Simplify.
Simplify. So what can we do is, for simplifying, we can take out, I can take out x square common from the numerator. I will get x minus 2 divided by, if I factorize the denominator, I will get x minus 3 into x minus 2. So x minus 2 gets cancelled. Now substitute the value and see, limit x tends to 0. 4 divided by
Minus.
So it is minus 2. Clear?
Yes, sir.
So this is how the problems are. This exercise you need not touch. I'll do it completely in the class. You can concentrate on your previous chapters. But before coming to the next class, I suggest you guys to recollect whatever I've told and come. If possible, work on your functions also so that you will have better clarity. Okay. So just give me a minute.